Welcome all. So today we are starting the basics of civil engineering, that is a course of RCC. So first we will do some numericals, some problems in singly reinforced beam, and we will follow the LSM method. So we will do the numerical. As I get time, I will also upload the theory lectures. Okay, so let's start. So first we are seeing the numericals. See, so we will revise a little bit the formulas and little bit of concept that are required for doing the numericals. We will revise that and we will move on. Okay. See, this is a singly reinforced beam, and this is the beam. Okay, and this is the strain diagram, and this is the stress diagram. Okay, this is the stress diagram and this is the strain diagram. So what all learnings we can take from here? See, this is the neutral axis. The depth of the neutral axis from the top of the beam is xu. Okay, and so this is the d naught. D naught is the effective cover in numericals. If it is not given in the problem, we take as the effective cover as is equal to 50 mm. Okay, so if the total d is given, we will deduct 50 mm, that is the d naught, the effective cover. We will get this effective depth, that is the small d. Okay, so above the neutral axis, this is the compression zone, and below the neutral axis it is the tension zone. Okay, so this is the rebars, the steel that is provided in the tension zone, so we call this as AST, area of steel in the tension zone. Okay, so here you can see this is the strain diagram. So why it is written 0.0035? There are some assumptions in the LSM that plane section remains plane before and after bending. So the second assumption comes that the maximum strain in the concrete side can reach up to 0.0035. Okay, and corresponding to that, the strain in that time in the tension zone in the steel, that will be 0.002 plus 0.87 fy divided by es. The formula is given here, and where is the 0.002 is coming? This is known as the proof stress. Okay, this is known as the proof stress. In this limit we can see the strain diagram also. Strain diagram, what is telling, the up till 0 point, this you can see this up till 0.002, the curve is parabolic as written here. The curve is parabolic, then it is rectangular. Okay, so see, this upper part is the compression zone. So the combined compression zone, compressive force that is coming is 0.36 fck b into xu. You have to remember this formula. This formula will be used. So c is equal to 0.36 fck b dot xu. And the lever arm, what is the lever arm? This is the lever arm. Lever arm is the distance between the compressive force acting and the tensile force acting. See, this distance and this distance, the distance between these two, the represented by the red color, is d minus 0.42 xu. Okay, d minus 0.42 xu. So what we can say, that this is the lever arm, this is the compressive force, and the tensile force is given here, 0.87 fy into ast. This is the tensile force. Okay, so we have to remember these things. Now there is another thing, that is MOR, moment of resistance. MOR, I am writing it here. MOR, that is moment of resistance, is denoted by the formula force into lever arm. Okay, so what we can say for tension zone, what it will be? So for tension zone, MOR for tension, it will be 0.87 FYAST. This is the force formula, and the lever arm will be D into D minus 0.42 XU. Okay, so and the tension zone, what it will be? In the tension zone it will be MOR tension, it will be 0.36 FCK B into XU into D minus 0.42 XU. So the force into the lever arm, just this thing. Okay, so this many thing, this is the learning from this image. We will go down and see some other things also. See, from here what we will see, how to find XU limit. Okay, so what is XU? You have seen here XU. See, you have seen here XU. So XU is the depth of the neutral axis. It is written here also, depth of the neutral axis. So XU limiting, the what is XU limiting? This is the maximum XU depth we can provide. Okay, so you will understand also. See what will happen then. XU limiting, the formula is derived, is given here. So the formula is K into D, where K, see here, the K is given here, the value of K is given here. So the value of K, what is, we can see it here for FE 250, 415 and 500. It is given as 0.53, for 415 0.48 and 0.46 for 500. You can see the same thing here also. Okay, and D is the effective depth, means capital D minus dg naught. Okay, so this small d is this thing. So you have seen the XU. Another formula we will need, we have XU limiting. Okay, so this is, sorry, XU limiting. So how we can find that XU? So we can see, we can derive here only, or you can derive here only. Okay, so I am seeing it here, XU. Wait, I need a blank space, so I will go to the down. Sorry, for, okay, I'll go to a down and add here. Okay, so we will see it here, XU. So how we will find XU? XU is the depth of the neutral axis. Okay, so in XU we can say that in another way, in the neutral axis the compression and the tension force is same. So C is equal to T. In the neutral axis, C is equal to T, compressive force is equal to tensile force. So we will write the two formula, 0.87 Fy AST and the tensile force 0.36 FCK B into XU. So from here, if this thing we take it down to this 0.87 Fy AST divided by 0.36 FCK B is equal to XU. So by this formula we will find XU, and mainly in the numerical, what we have to do, we have to find the XU, the XU limiting, the moment of resistance. What is the moment of resistance? The force into the lever arm. If we take out the moment of resistance from the compressive side, we will take the compressive force formula, and if we take out the tensile side, the moment of resistance, we will take the tensile force formula. Okay, so once again I am repeating, this is the compressive force and this is the tensile force. Okay, you have to just multiply with, for moment of resistance calculation, we have to just multiply it with the lever arm. The lever arm is just D minus 0.42 XU. This is the lever arm. Okay, so if we are left anything, Yeah, we have done everything. Okay, we can write it the formula here also. XU limiting, what we saw, is equal to K into D, A into D. Okay, and the moment of resistance for the compressive side is what? 0.36 FCK B into XU, multiply it with the lever arm D minus 0.42 XU. Okay, and if we take out the moment of resistance from the tension side, it will be 0.87 Fy into AST, multiply it with the lever arm D minus 0.42 into XU. Okay, so another thing is left. Wait. Okay, so what we will see that if XU limiting is greater than XU, if XU limiting is greater than XU, then what is? Then it is a under reinforced section. Under reinforced section means the neutral axis you are providing is less than the limiting value, so it's okay, it's under reinforced. In that case, we will use XU in all the calculation. Okay, if XU limiting is XU is greater than XU limiting, then it is over reinforced. Okay, over reinforced. So IS 456 restrict us to use over reinforced section. So in that case, what we will take? We will use XU limiting in our all calculation. Okay, and in under reinforced case, we will take the moment of resistance. We will find out the moment of resistance from the tension side. Okay, if it is over, we will find out it from the compression side. Okay, and if mu limiting, if XU limiting is equal to XU, then it is a balanced section. Okay, balanced section. So while we will design a beam, we will use this. We will take it as not as under reinforced, not as over. We will take it as balanced section while we will design a beam. Okay, so now let's check. Yeah, so this we have done. Okay, this page we have also done. This page was only for this XU formula, XU limiting formula. Okay, again we will see what is in this page. In this page, what formula we needed? We need this formula, AST, area of steel. Okay, area of steel formula is needed. AST is equal to mu limiting. Okay, mu limiting divided by 0.87 Fy into J into D. Okay, so where J is the lever arm coefficient, and the formula is 1 minus 0.42 K. Okay, and the K you can find it from there. The K value as for a Fe 250 we get it as 0.53. Okay, for Fe 250 we can get it at 0.53. For Fe 415 we can get it at 0.48, and for Fe 500 we can get it at 0.46. This is the value of K. We can find it, the J value, and we can put it here, and D is the effective dead. Everything we know. We just don't know the mu limiting, moment limiting, how to find it. So we will see it. Okay, so here also there is a formula to find the number of bar. Okay, for number of bar, finding the number of bar n, we will divide it the AST and divide it by pi by 4 the dia square. The phi is represented as dia. Okay, And the spacing, how we will find this spacing? S is equal to 1000 divided by, okay, we are finding it for 1 meter, 1000 divided by AST into pi by 4 phi square. Okay, so this formula is a good one. We can write it, we can write this formula in another way also. Okay, so I will write it for you. See if you can appreciate it. See, this formula can be written as AST is equal to mu limiting divided by 0.87 Fy, just multiply it with the lever arm, d minus 0.42 xu. Okay, so how we are writing this formula? We are taking d, okay, and d, we are taking it d here, from we are finding it d, and this j is represented as 1 minus 0.42. okay, so see, if we multiply d and k, what we will get? D minus 0.42 k, okay, kd, sorry, kd, and k is equal to, and you can see it from here, wait a minute, see, k is equal to 0, k is equal to xu limiting divided by d. Okay, so we have kd, so we will multiply it, so d both side. So what you are seeing, the d is just cancelling. So what, so see what we have written, t minus xu, as because you can see here only xu is remaining, everything is cancelling out. So this is also a formula, this area formula can be written in this way also. Okay, so you can mark it also this. So now just one thing is left. We have seen mu limiting in this AST formula, area of steel calculation. See, this mu limiting will be find out from here. Mu limiting is equal to q into b into d square. Okay, so what is q? Q can be find out from this chart. See, q value is given for every Fe value. Fe 250, the q is 0.148 FCK. For Fe 415, the q is 0.138 FCK. And for Fe 500, the q is 0.134 FCK. Okay, so by putting this value in this one, q, we know q, and b and d will be given. So mu limiting will find out, and if you get the mu limiting, you will get the AST. Okay, so we will now just start the numericals. Okay, see, first we will read out the numerical given. Determine the depth of the neutral axis. So what is the neutral axis? Neutral axis is xu of a beam section given as 250 into 400. Okay, so small v is 250 and capital D is 400. Okay, size of reinforcement given is 3 bar of 20 dia. Okay, dia bar. Fe 250 means Fy is given as 250 and made up of M20 means FCK is given as 20 and effective cover is 50 means D naught is given as 50 mm. Okay, so first thing what we will do, see, we are doing it here. Okay, so first thing we will write the XU formula. So first we are calculating XU limiting. Okay, XU limiting is equal to, As we know, we have written here, if the beam is under reinforced, we will take the value of XU. If it is over reinforced, we will take the value of XU limiting. Okay, so XU is equal to K into D. You can check it here. It is given as FE 250. Okay, if FE 250, so the KD value will KU limiting will be, the K value for FE 250 is 0.53 into D. D is, see, the capital D is 400 and the cover is 50. So 400 minus 50. 400 minus 50. So 0.53 into 350. So you calculate it with me. We'll just not waste time in calculation. You just calculate it on your own. Okay, so XU limiting is coming as 185.5 mm. Okay, yeah. So now what we will do, we have find out the XU limiting. Now we will see the XU formula. XU is equal to 0.87 FYAST divided by 0.36 FCK B. You can just remember the two formula of the force, that is the compressive force divided by the tensile force. Just the XU, the here XU will be taken to here. Okay, nothing else. Yeah. So now we have Fy, we have FCK, we have B, we have, just we have to calculate the AST. So we will calculate the AST. We have given that 3 bar we have of dia, I think 20 mm. Let's check it. Of dia 3 bar of 20 mm. Okay. So the area is coming out as 942.5 mm square. Okay. So now we will just put the value here. We will just put the value here. 0.87 into Fy. Fy is 250. See, Fy is 250. So we will put it here, 250 into AST is 942.5 divided by 0.36 into FCK. FCK stands here, FCK is 20. So we will take it as 20, and the beam width is as, see, B is 250. So the B is 250. So we will calculate it. So we are getting it as 113.26 mm. So what we can conclude, XU limiting is greater than XU, so it is under reinforced. Okay, so it is under reinforced. Okay, so we will take the value of XU. Neutral axis depth will be 113.26 mm. Okay, so this is the answer. Okay, so the numerical is completed. So we will shift to the next numerical. Okay, so let's see what it's given. Determine the lever arm. We have to find the lever arm. Okay, so lever arm formula is D minus 0.42 XU. Okay, lever arm for a rectangular beam of size, so we have to find the XU. So for XU we have to find the XU limiting first. and then XU. For XU calculation, what we need the AST value also. Okay, so let's check. We are not writing the given. See here, the given is the beam size dimension is given, the cover is also given, FCK is 25. Okay, the dia of the bar is given, and FE 415 is given. So let's start. So we will see that XU limiting, we will find it as XU limiting is as K into D. Okay, so K value for FE, see here FE 415. So if for FE 415 the value is as 0.48 into D. See, the D is given as 450 and the cover is 50, so we will take D as 400. Okay, so it is coming as 192 mm. Okay, so now what we will do, we will find out the AST. Okay, AST is equal to, see, it is 420 bar 4 into pi by 4 into 20 square. Okay, so it is coming as 125.664 mm square. Okay, so AST is coming as this. So now the work is over, so D minus 0.42 XU. So see, we have to now calculate XU is equal to 0.87 FY AST divided by 0.36 FCK into B. So we will get it from here. 0.87 into Fy is as 415 into AST as 1256.64 divided by 0.36 into FCK is as 25. Okay, 25 into B is as 300. Okay, 300. So we will calculate it. So the value is coming as 167.11. Okay, 167.11 mm. Okay, so you can find that XU limiting is greater than XU. So XU limiting is greater than XU, so it is under reinforced. Okay, so we will take the XU value as 167.11. So here D is taken as 400 minus 0.42 into XU as 167.11. 167.11 is equal to 330.48 mm. This is the lever arm.